the first few steps were basically just understanding the basics of the system. So we went ahead and familiarized ourselves with OCPP, which is the industry standard and the UK government's legally required protocol that is supported and has to support for any EV charger that's sold for home use in the UK. The UK government had very strict requirement in terms of what is a minimum viable system that needs to happen. The other part the UK government was quite strict on was the fact that the entire software stack cannot be locked into, which means that as an end user, if I'm purchasing an EV charger, I have the option to switch over to another software stack, and you're not tied into the software that's provided by the hardware seller, in our case, Brim. That resulted in us building an entire application stack with mobile apps, web apps, a lot of backend infrastructure, which was built in a opt-in, opt-out kind of a way. We built in a lot of offline first tooling. We built in a lot of tooling to support the different types of functionalities user may had. For example, schedules, maximum current, understanding how the rest of the house is behaving in terms of energy demands and adjusting around it, reporting accurately for all the different um, types of data that is being generated throughout the day. For example, using CT clamp to understand how the rest of the house is performing, as well as understanding user behavior patterns on how often someone needs a charge, and identifying some thresholds of what the maximum charge a car would pull. Then we extended ourselves into the next layer, which was this grid layer. So we were no longer thinking about just one car. We were thinking about a group of cars, a group of EV cars that have to be charged overnight within a limited threshold of a grid. Imagine a complex built of, let's say, a few hundred houses or few tens of houses who have a limited energy, like a limited amount of energy that can be pulled, which is shared between the houses using the energy themselves as well as the cars needing the energy. So we had to understand different types of cars, their behaviors, and then prioritize different cars throughout the night so that everyone's car is fully charged in the morning without overwhelming the grid and potentially shutting it down. So when I'm saying a grid, I'm not saying, of course, the entire city or that area's grid. I'm talking about a smaller grid for that housing complex, which has one parent master line, or like one for each phase. Once we had solved that, we went into the next problem statement, which was building commercial car parks out of it. Anyone who wanted to understand or offer their own EV chargers, um, um, and the space they had available to them, to generate revenue from those EV chargers by commercially making them available for others in a commercial car park, for example. So we had to build the entire stack of allowing people to basically get paid for setting up these charges. They could define the energy price per unit, defined throughout different parts of the day. You would have cost for holding an EV charger on hold by leaving the car plugged in even when the car is fully charged, and a few other types of pricing that was built into the system. Um, so yeah, one recommendation always is, um, try to go as close to the hardware as possible. But of course, it's a different domain. It depends on the amount of cost you want to spend on that. The other big one you always find out is custom protocols are always hard. This protocol specifically was built on WebSockets on a two-way asynchronous communication, and a lot of the times, what you would realize is that the hardware was just sometimes slow to respond, sometimes had compute problems, and most of the times it was just uh, the network was patchy along the way. And you would end up in these edge case scenarios where you had to wait in an undefined state for a long time, waiting for the firmware to catch up, grab network again, send the missing data, so that you can continue, because of how these protocols are written in the first place. So by being more close to the hardware and controlling the firmware, you can give a more smoother experience. And the last one is, anything hardware, you have to build your entire stack in an offline first way, which allows the experience of the end user to be as seamless as possible, irrespective of the quality of network. So I would say those three things are quite useful. But at the end of the day, hardwares are just hard. Um, and yeah, you have to just cautiously make sure that your problem statements um, consider into the fact that anything custom protocol and anything hardware will come with its set of pitfalls, and you have to accommodate for that scope in advance.